Okay, what we're going to look at today, and I guess it's not really section 5-4 because this is a different textbook, so it doesn't matter, but it's just the sum and difference of angles formulas. One of the things you'll notice, you can look down here at my first example, we're asked to find the exact value of cosine 75 degrees. Well, if you take a look at your unit circle, you're going to see you don't have 75 degrees on your unit circle. So far we have not been able to find exact values, and we have depended upon our calculators to come up with those, and your calculator won't tell you exact values. It gives you a rounded decimal approximation. So we do have some formulas we can make use of to find some of these trig values of angles, and this is what they look like. And I know it looks really complicated. So for the sine, and we have two angles, so I'm going to use alpha and beta. So if you wanted to evaluate sine of alpha plus beta, just the plus, then you'd have to calculate sine of alpha times cosine beta plus, because I have a plus sign up here, so it's plus, cosine alpha times sine beta. If you wanted to do sine alpha minus beta, you would do sine alpha cosine beta minus, so they match up here, the bottom ones, cosine alpha sine beta. If you needed to evaluate cosine alpha plus beta, you would do cosine alpha times cosine beta and then minus. So use the top sign if you're using plus. Then you do sine alpha times sine beta, and then the last one, cosine alpha minus beta, is cosine alpha cosine beta plus sine alpha sine beta. So I know that sounds really complicated. These are formulas that are actually not hard to remember, but you'll probably laugh at me when I tell you, but that's okay. So I kind of remember it by doing kind of a little sing-song type of thing, and it goes like this: sine, cosine, cosine, sine, cosine, cosine, sine, sine. And it kind of helps you remember. And you can play that back again and listen to it, so I won't have to do it again. And then remember that sine keeps the same sign. Get it? So we have, if it's plus here, it's plus here. If it's minus here, it's minus here. So sine keeps the same sign. Notice that cosine does not. So how do we use those? So to use this, to find the exact value of cosine 75, I need two numbers that either add or subtract to 75. So I'm going to use, and they need to be values on the unit circle. So I'm going to think of cosine 75 degrees as cosine 45 degrees plus 30 degrees. Notice I'm using degrees instead of radians. This really is easier to use degrees for these. So I'm using the addition form for cosine. So the formula I'm going to use is cosine alpha plus beta. So this one is cosine, cosine, sine, sine. So cosine, cosine. Notice they switch the angle. This does not keep the same sign. Sine, sine. Okay, now instead of an alpha, I have a 45, and instead of a beta, I have a 30. So I'm going to have cosine 45 degrees. That's a degrees, starting to make a percent. Times cosine 30 degrees minus sine 45 degrees times sine 30 degrees. Okay, I didn't mean to do that. Okay, so here we go from here. I'm going to ignore where I wrote my formula. So cosine 45 degrees is the square root of 2 over 2. If you don't know that, get out your unit circle. Cosine of 30 degrees, I remember sine 30 degrees is 1/2, so this must be root 3 over 2. Minus sine 45 degrees is root 2 over 2. Times sine 30 degrees is 1/2. Again, hope you're good with fractions. You're just multiplying this time. Square root of 2 times square root of 3 is square root of 6. 2 times 2 is 4. And here we'll have the square root of 2 over 4. So then my answer is root 6 minus root 2 all over 4. And this is an exact value. This is my answer. You can check it out if you grab your calculator and make sure you are in degree mode and evaluate cosine of 75 degrees. And then in your calculator, plug in square root of 6 minus square root of 2 all over 4, you will see that you get the same value. So identify the two angles you're going to use to either add or subtract to 75, and identify the formula you're going to use, and then substitute the values using your unit circle. Here's another one. Find the exact value of sine 15 degrees. Well, I'm going to have to subtract two angles. Well, that would be the easiest way anyway. So I'm going to think of sine 15 degrees as sine 45 degrees minus 30 degrees. So you can look back at the formulas. I'm using sine alpha minus beta. And if you want, you can write that down. So we have sine alpha minus beta. This one was sine, cosine, cosine, sine. And you keep the same sign. So plugging that in, I'm going to get sine 45, cosine 30, minus, because it was sine, cosine, cosine, sine. So cosine 45 degrees times sine 30 degrees. Okay, once you have those values placed in there, now you can just look on your unit circle. If you don't have these memorized, we get root 2 over 2. Cosine of 30 degrees was root 3 over 2. Cosine of 45, root 2 over 2. And sine 30 is 1/2. So we get root 6 over 4 minus root 2 over 4, which is root 6 minus root 2 all over 4. And I know what you're thinking. Just like in the last video, everything was 1. Here you're thinking, wow, every time we do one of these, we get the same answer. No, but you do have the same values show up all the time. If you think of those unit circle values, it's square root of 2 over 2, square root of 3 over 2, and 1/2. Those values are going to show up all the time when you're dealing with sine and cosine. So that's typically what's going to happen. You'll have similar values, might be plus or minus, things might be switched around, but they are going to be very similar. Okay, here's one that says use the difference formula to simplify cosine 90 degrees minus theta. So this time a little different, and I'm still going to use a difference formula, so I'm going to start by writing it down. So cosine alpha minus beta. Remember, it's cosine, cosine, sine, sine. And we change to the opposite this time. So now I'm going to use it for the 90 minus theta. So for cosine 90 degrees minus theta, I get cosine 90 degrees, cosine theta, plus sine 90 degrees, sine theta. Now if you look at your unit circle, 90 degrees is at the top of the unit circle. Remember, cosine is the x-coordinate, so it was 0. So I get 0 times cosine theta. And remember, sine 90 degrees, at the top, sine was the y value, so it was 1 times sine theta. So we get 0 plus sine theta, which is just sine theta. So I started with cosine. So we had cosine 90 minus theta equals sine theta. And this actually, since we just proved it, this is an identity. And remember what I talked about, how cosine got its name? Because it's complementary to sine, and two angles that add up to 90 degrees, complementary angles. So that's, and also remember the graphs, how if we shifted the cosine graph over 90 degrees, it coincided with the sine curve. So that's, this is an identity that shows that. So here's one for you to try. See if you can simplify sine 90 degrees minus theta using the correct formula. So I'm going to go ahead and do this, but you can pause this and try it and make sure you know how to do that, and then push play when you're ready to go on. Okay, so we're going to do sine alpha minus beta. So it's sine, cosine, cosine, sine. And we are doing this with a 90 degrees instead of alpha, and then a theta. So I get sine 90 degrees times cosine theta minus cosine 90 degrees times sine theta. Remember, sine of 90 degrees is 1, so I get 1 times cosine theta. Cosine of 90 degrees is 0. So we just get, on the left side, we had sine 90 minus theta, and we get that equals cosine theta, which shouldn't surprise us. Again, this is an identity, and we see shifting that 90 degrees, either one of them is going to produce the other curve. Okay, so here's another one. We're going to prove that cotangent theta equals tangent of 90 degrees, or 90 degrees minus theta. So typically I start with the more complicated side. So I'm going to start with tangent 90 minus theta. Now, we don't have a formula, well, there is one, but it's a little more complicated. So I'm going to make use of what we already know, and that is tangent is sine over cosine. So I'm going to think of this as sine 90 minus theta over cosine 90 minus theta. Whatever we've already proved, and we actually, I guess, didn't, oh yeah, we did prove this from the unit circle, but once we've already proved it, we can use it. So I'm going to make use of that. Well, we already know what sine of 90 minus theta is because we solved that, and we got cosine theta. So I'm going to have cosine theta in the top. And we solved cosine 90 minus theta right here. We got sine theta. So I'm going to have a sine theta in the bottom using what I've already proven to be true. Well, we already know that cosine theta over sine theta is just cotangent theta. And we're done. So we just did a proof because notice we did not use any numbers substituting in. We used variables and we used things that we had already proven to be true. Okay, so the last one here, and this gets a little complicated. So suppose alpha is an angle in quadrant 2 and beta is an angle in quadrant 3, such that sine alpha equals 4/5 and cosine beta equals -3/4. And what you're asked to find here is we're asked to find the exact value of cosine alpha. So what I'm going to do on here, and you can do a couple different things. You can use the Pythagorean identity, or you can use triangles. I actually think it's easier to use triangles. So we know that in quadrant 2, all students take calculus. So sine is positive, which means cosine is negative. So we know it's going to be negative. So I'm actually going to just draw my triangle. And here's alpha. So we have opposite over hypotenuse. So this is a 3, 4, 5 triangle, clearly not drawn to scale. So cosine alpha equals adjacent over hypotenuse. Remember we said it was quadrant 2, so it's negative. So we're going to get -3/5. And now for part B. You didn't see there was a part C, did you? Find the exact value of, to be perfectly honest, I forgot it was there. Find the exact value of sine beta. So to find sine beta, we need a different triangle, even though it kind of looks the same. And this time cosine is 3/4, so I'm going to have a 3 here, a 4 here, and I know it's negative. Beta is in quadrant 3, and sine is negative in quadrant 3. So I know that my answer is going to be negative. 4 squared minus, so 16 minus 9, we get 7. So we'll have the square root of 7 on this side. So I have sine beta equals, we said it was negative, so -√7 over 4. Okay, then I have another question, this part C right here, that says find the exact value of sine alpha minus beta. So using the formula, sine alpha minus beta equals sine, cosine, cosine, sine. Remember, it keeps the same sign, so it's going to still be minus. Now, I'm going to go and use the values that I've just found and plug these in. So I need to know, what is sine alpha? Well, sine alpha was one of the ones given to us. So we had 4/5. So I'm going to plug in a 4/5 times cosine beta. Cosine beta was one of the ones given to us. We had -3/4. So we'll put in a -3/4. Oh, somehow I changed my pen color. Minus cosine alpha is one that we just found. We got -3/5 times sine beta we just found was -√7/4. So now we have, multiply these, we get -12/20. And you know, I could cancel out the 4's, but I'm going to end up subtracting this, so I'm going to need a common denominator anyway. So I'm just going to hold off on that, leave it -12/20. Minus, multiply these, you get, when you multiply negative times negative, it's going to be positive. 3 times √7 is 3√7/20. So now I get -12 minus 3√7 over, my common denominator is 20. So I'm going to leave it like this. Okay, now remember, you can't cancel the 12 and the 20 because it's part of a sum or difference. If you cancel it over here and reduce this, then you just wouldn't combine these two things, but you can just simplify it like this. Now, here's the deal. If I had not asked you to do part A, and I had not asked you to do part B, and I only asked you to do part C, you would still have to do part A and part B, because in order to find sine alpha minus beta, you have to know all 4 of these parts. So if you're only given 2 of them, you have to find the other 2 by building triangles in order to put it together to use a sum or difference formula. So be careful on that. Don't just avoid the temptation of just saying, oh, this must be sine alpha minus sine beta. It doesn't, just kind of like thinking of it like distributing. It doesn't work that way. So you have to use one of those 2 formulas.